Welcome back to Algebra 1, Chapter 10, Section 7, Factoring Special Products in that book. That's why I held the book. So anyway, there are certain things in math that are really, really important. And there are other things that are not so important. And this is actually one of those that to me, now there are probably math teachers who would gasp in horror at what I'm about to say. But to me, this is not very important because what it is that with certain factoring, there's patterns to it. But what I have found as a tutor is that when I tutor kids for the SAT and the ACT and college entrance exams, under pressure they tend to forget the special formulas that go with the special patterns. And you can always get the answer not using the special patterns, but so to me it's just one of those things that's fine if you know it, fine if you don't. The more you do algebra, the more you'll start seeing it and remembering it. But trying real hard to memorize it right now as an Algebra 1 student, I haven't seen good success with that. So anyway, special factoring. So here we have a problem, m squared minus 4. So this is the same thing as if it, let's make it an x. I just really like x's better. This is the same thing if it was x squared plus 0x minus 4. Now it looks a little more normal, doesn't it? So if we were to factor it, we draw our parentheses, we put our x's here, and then we think, what are the factors of 4? Well, they're 1 and 4, 2 and 2, and which ones can we pick that are multiplied, you get 4, but added or subtracted, you get 0. Well, we could do 2 minus 2, and that would make it 0. We would just need 1 plus and 1 minus. Does it work? Plus, minus, those will go away, and 2 times negative 2 is negative 4. So that's it. So if that middle term is missing, a lot of times it'll be plus and minus of the same thing, because you've got to have them go away to make that middle term 0. Okay, so here's another one. Same thing, that we want our middle term to go away. But we know that 4 is 2 times 2 and 25 is 5 times 5. So if we make them the same and make 1 plus and 1 minus, then the middle term will go away because these are going to be the same. That's positive 10x and that's negative 10x. And it will be negative there. So this is the difference between two squares, is what the name of it is. This one looks awful. Let's put it in the right order. Negative 98x squared plus 50. That looks better. Sometimes you have where a number goes into both of them and you can do what I call pulling it out. And we can pull out a negative 2 here and have 98x minus 50, not 98, I didn't divide it in half. Whoop, whoop, whoop. Pretend that didn't happen. My phone just done, so part of my head thought, ooh, do I need to listen to this? 49 minus 25. And remember this equals 0, so we could divide by negative 2, divide by negative 2, 0 divided by negative 2 is 0, and it really just makes all of that go away. I showed you why, but in reality you can pull it out and pretend like it never was. So now we have the difference in two squares. So we could put 7x on both of the beginnings and 5 on the ends, and one needs to be positive and one needs to be negative for that to be a negative 25. Okay? How about this one? This one looks interesting. It's a different pattern. This is x squared, so those are just x's and x's. What could you multiply to get 4, but added or subtracted to get 4? Oh, we know it's 2. 2 and 2, right? So the bigger one of these has the sign of this, but they're both the same. And then you look and say, what sign does this one need for that to be positive? Well, it has to be negative because 2 negatives make a positive. So with this one, these are the same, and you can write it, and you usually see it written this way. Because that means it's just 2 of these multiplied by each other, but it's the same thing. This parabola is sitting on the line at 2 because it only has one answer. Remember, it's the opposite sign. It looks like that, where these have 2 places. These are the ones, these will be crossing at plus or minus 2, like that. Okay, this one is just ugly. Now I think we might could pull something out for, no we can't. Okay, so the other thing is, how you really do these complicated ones is you use a calculator. You're going to use the quadratic equation program and put it in and get the solutions first and work back to the factors, alright? So on my calculator, I'm going to go to program. I'm selecting AQUAD. You might not have this program, but you can get it. It's out there. You can get it from me or from the Texas Instrument website. First it asks for the A term. The A term is 16. The B term it asks for next is 24. And my C term is 9. I hit enter and it tells me that my answers are -3/4. So the solution equals -3/4. How do I turn that into the factors? Well, it only gave me 1, so I know it's going to be one of those squared things. And this, the numerator goes over here. You put the opposite sign down, and then the denominator goes over here with the x. Ta-da! That's not bad, is it? Here's another one where we can pull something out. We pulled out the 3. It goes away. Then you say, okay, what can you multiply together to get 25, but add or subtract to get 10, and it's 5. And it needs to have the sign, one of them needs to have the sign of the middle one. What does the other one need to have for it to be positive 25? It needs to be -5. So this would be written x minus 5 squared, and the solution, remember, is the opposite, is plus 5. That's the parabola sitting on plus 5. Okay, here's another one that you can pull something out of. -2 goes into all of these. So you take a -2 out of that, you divide that by -2, and you get -6, and you divide that by -2, and you get +9. Notice, since I pulled out a negative, all the signs changed. This one became positive, that one became negative, that one became positive. So now remember, the 2 goes away because I get rid of it by dividing it into 0. And then I ask myself, what can I multiply together to get 9, but add or subtract to get 6, and it's 3. One of them has to have the sign of the bigger one, but they're the same size of the middle term. Then what sign does this need to have for that to be positive? And it needs to be -3. So this is x minus 3 squared. The solution is 3. But the thing is, the way we pulled out a negative, do you see how this leading coefficient is negative? That makes my parabola go down. So this is another one. You can take these and type them in exactly like this into your calculator, and it will graph it for you. And then you can see the solution by looking at the graph. And you can do zeros, or you can also do your second line being, make y2 equals 0. And then you can do intersect, and where those intersect will be your answer. So my x is at +3. I shouldn't have written a negative there. My x is the opposite sign. It's +3, but it's going down because of that -2 right up there on the leading coefficient. So make sure you erase that in your head right there. I shouldn't have written negative right there. The solution is +3, but the parabola is going down. This is another one. I would just do it in my calculator. The A term is 1, the B term is 1, and the C term is 1/4. You can do 1 divided by 4 or 0.25. Your calculator can do it. It tells me the solution is -1/2. So how do I put that? I put my x, this is the numerator, the sign is opposite, and that the denominator goes over there. And it's a perfect square. We only have one solution, so we know it's squared. Ta-da! So this is a upturned parabola sitting on the x-axis at -1/2. All right? So learn how to do these. Not so much those, but learn how to do all these on your calculator. Watch the calculator lab, practice it, and you'll do great. Math is great. See you next time.